Let's get started on Chapter 1, Introduction to Computer Networks. In this chapter, we will look at the components of a PC, a personal computer, and the components of a local area network. We will look at a peer-to-peer network and a server-based network. We will look at different types of servers. We will look at the difference between a LAN and a WAN. We will look at packets, and we will look at binary. So let's start out on page 2, an overview of computer components. In this section, we look at the components of a PC, of a personal computer. And you might ask, if this is a networking class, then why do we study the components of a personal computer? And the answer is, a network is really nothing but a whole bunch of computers which are connected together with wires or wirelessly. So let's do a brief overview of personal computer hardware. PC hardware can be divided into input, processing, storage, and output hardware. Here's the example. The user types in the data, 2 plus 2, to the input hardware, the keyboard. That is then sent to the processing hardware, and the addition of 2 plus 2 is done in the processing hardware. Then the result, the number 4, can be output to output hardware, the monitor, or it can be output to the printer, or it can be stored to the hard drive. 4 major components of microcomputer hardware. The system unit, also just called the box, contains probably the most important part of a microcomputer, and that is the microprocessor. If we look at the inside of the system unit, we can see that the system unit includes the power supply and the hard drive and the DVD drive, but most importantly, it includes the motherboard, the big flat circuit board sitting on the bottom. And if we look at the motherboard, we can see that the motherboard is a plastic circuit board, and mounted on the motherboard is the microprocessor, RAM, and the bus. A microprocessor is the only part of the computer that can add 2 plus 2. It's the most important chip. It does the processing. And RAM, random access memory, is current memory, and it holds whatever the computer is working on. And the bus is the little wires printed on the motherboard that connects RAM to the microprocessor. Storage devices. You can store data to the hard drive. Data can be stored to a DVD drive, and data can be stored to the USB drive. A controller card, there's several types of controller cards, and a controller card is also known as, a.k.a., also known as an expansion card, or an adapter card, or an I/O card. And here are 3 different examples. You could have, for example, a video card or a network card, and obviously that's what we're most interested in, or you could have a sound card. So these cards are typically plugged into a slot in the motherboard, or they might even be built into the motherboard. The BIOS, introduced on page 8, stands for the Basic Input-Output System, and the BIOS controls the boot process on the motherboard. To run the BIOS setup, you turn the computer on, and usually you press F2. On some computers you press F10, or some computers you press delete. To run the BIOS setup, this brings up the BIOS setup screen. The BIOS setup screen allows us to set the date and the time and the boot order. The BIOS setup allows us to set the date and the time, to specify whether or not a floppy disk drive is connected. Usually it's not going to be, but older systems, it may be. most importantly, it configures the boot order on the motherboard. And this BIOS setup information is stored on a chip, which is called CMOS, complementary metal oxide semiconductor. And CMOS information is maintained by a battery. So if your computer keeps losing the time and the date, it could be that the battery on the motherboard is going dead. So, in summary, the components of a personal computer include input processing, output, and storage hardware. The system unit is the box which contains the motherboard. Mounted on the motherboard is the microprocessor and RAM. You can save data to the hard drive or the USB drive. A controller card is a circuit board that plugs into the motherboard, and in our case we're concerned with the network interface cards. And the BIOS is the basic input-output system. Now, let's move on to page 14 and discuss the fundamentals of network communication. Let's start out with the hardware components of a local area network. You've got a client and a server. The client is the workstation where the user is standing, and then the user can log into the server and save files to the server. The workstations are connected to the server by way of a hub or a switch. I'll tell you the difference later on in the course. And then the network interface card is in each computer, and it allows the computer to connect to the switch. Let's look at the network interface card. The network interface card is a circuit board that plugs into the motherboard on the workstation, or it might even be built into the motherboard. And the point is, the cable plugs into the network interface card. You gotta have a network interface card if you want to connect to the switch. Even for wireless, you have to have a wireless network interface card. So the network interface card is in each PC, in each workstation, which connects to the cable, which connects to the switch, which connects to the server. These are the major components of a local area network, and it's what we will be working with mostly in our careers as network technicians. Now let's look at networking software, operating system software and communications software. In a local area network, you've got workstations, which are called clients, and servers. And the client would have an operating system, and for example, that would be Windows XP or Windows Vista or Windows 7 or Windows 8 or Windows 10. And the client has an operating system, and then the server has an operating system as well, and that's called the server operating system. It's also called the network operating system, and of course an example of that would be Windows 2008 or Windows 2012 server. And then TCP/IP is communication software. Stands for Transmission Control Protocol, Internet Protocol, introduced on page 19. And the purpose of TCP/IP is it is a piece of software which allows computers to communicate. So let's look at it. If we go to a Windows 7 machine, or it looks the same on Windows XP or Vista or even on Windows 10, you click on Start, go to Control Panel, and then you select Network and Internet. Then you select the Network and Sharing Center, and on the left, click on Change Adapter Settings, and then you will see this is our network interface card. Right-click on this guy and select Properties. And there we can see there's TCP/IP. It is installed. There's the little checkbox. We can see that it's installed. And then if we look at the description, we can see that the Transmission Control Protocol / Internet Protocol is the default wide area network protocol that provides communication across diverse interconnected networks. And then if we look at the properties of TCP/IP, we can see that each computer has an IP address. we'll talk about IP addresses in Chapter 5. Another way to view the IP address of the current IP address of the computer where you are is the ipconfig command. To use the ipconfig command, you go to the command prompt and you just type ipconfig and you press the enter key. And then it shows you the computer's current IP address and default gateway, which we will discuss later. TCP/IP is the software that allows computers to communicate, and we will discuss it in greater detail in Chapter 5. Page 34 discusses networking models, peer-to-peer and server-based. A peer-to-peer networking model would only be used in a very small organization. In a peer-to-peer network, there is no file server. You have a number of workstations which are connected to a switch, and anybody can access anybody else's hard disk. And I guess that's not so bad if you only have 2 or 3 or 4 co-workers. But you've got 100 people working together. That's just not a good way to go. So the peer-to-peer network is only for a small office with a small number of users. Most of us are going to be working on server-based networks. In a server-based network, we have a separate, dedicated computer to be the server, which has a big old hard disk on it, and then everybody can log onto the server and they can save their data up to the server. Peer-to-peer network only for a very small office. Most of us will be working on server-based networks. Now, you got a couple different types of servers, which we will be discussing throughout the course. You've got a file server, which is a computer that everybody can save data to. A print server, database server, a web server, an application server, and an email server. And one type of server that I would like to, in particular, bring your attention to is called a domain controller. It's also called a login server. And a domain controller has Active Directory installed on it. And Active Directory is a database of usernames and passwords that allows users to log in. So a domain controller is also called a login server, and what makes it a domain controller is the fact that it has a centralized database of usernames and passwords that allow people to centrally log on. And we will talk about more about domain controllers as we get into the course. Networking terms, local area network versus wide area network. I think we all know what a local area network is. That's going to be a small network. This would be a single segment local area network, such as a small office or one classroom here at CCBC. Now, you could have a larger local area network. This would be a multi-segment local area network. So here's a network, a bunch of workstations connected by a switch. Here's a network, a bunch of workstations connected by a switch. Here's a data center, a bunch of servers are connected to a switch, and then all the networks are connected centrally together to a router, which connects to the internet. And this is a diagram of the CCBC Catonsville network, all of which we will look at as we get deeper into the course. But this is still considered a local area network because it's one geographic area. It's a big local area network, but it's a local area network. Now, a wide area network means it's over a greater distance. The internet is a wide area network, so you could be here at CCBC and then access a computer over at UCLA in California. Local area network would be one geographic area. A wide area network would be all the way across the country. A metropolitan area network would be within one city, such as the Johns Hopkins University, which is pretty big, located throughout the city of Baltimore. And then a SAN, a storage area network, we'll talk about that later on in the course. A packet is introduced on page 30. Very important to understand what a packet is. A packet is a message which is made up of data which is being sent from one computer to the other, and it has a header on it that shows who that data is going to. But before we can understand what a packet is, we should look at communications between computers. Computers can only send positive and negative impulses to each other. So if this computer is going to send the number 7 to this computer, but it can only send positive and negative impulses to that computer, how can it send the number 7? And the answer is it will send 5 negative impulses and 3 positive impulses. And that combination of positive and negative impulses represents the number 7. Each positive or negative impulse is called a bit, stands for binary digit, and it can be a positive or a negative impulse, but we typically write it as a 0 or a 1. So the point is, computers can only send positive and negative impulses to each other, and different combinations of positive and negative impulses represent different values. So why do 5 negative impulses and 3 positive impulses equal the number 7? This takes us to binary math and binary notation. So we're going to jump up to Chapter 5, the TCP/IP chapter, and we will see that when one computer sends 8 positive or negative impulses to the other computer, each positive or negative impulse can be assigned a value. So we have 8 values here, 8 placeholders, 1, 2, 4, 8, 16, 32, 64, 128. And a negative impulse, a 0, means absence of a value, and a positive impulse, a 1, means presence of a value. So here's the example. If one computer sends 7 zeros and a 1, or 7 negative impulses and a positive impulse to the other computer, it is actually sending the number 1. How do you get that? Well, we have 1, 1, but no 2s, no 4s, no 8s, no 16s. Now, if one computer sends 6 zeros, a 1 and a 0 to another computer, it's sending the number 2. How do you get that? Well, we have no 1s, and then we've got a 2, but no 4s, no 8s, no 16s. So that represents a 2. If one computer sends 6 zeros and 2 1s, or 6 negative impulses and 2 positive impulses to the other computer, it is sending the number 3. How do you get that? Well, we have a 1 and we have a 2, and you add them up and you get 3. If we have 5 negative impulses and 3 positive impulses, 5 zeros, 3 1s, that equals 7. How do you get that? We have a 1, we got a 2, we got a 4, but we have no 8s and no 16. So in this case, 1, 1, and 1 is equal to 7. Another example. If we have a 1 followed by 7 zeros, that represents the number 128, because we have a 128 and nothing else. And if we have a 1, 6 zeros and a 1, then that represents 129. How do you get that? 128 plus 1 equals 129. If one computer sends 8 positive impulses to the other computer, it is sending the number 255. How do you get that? That's what you get when you add up 1, 2, 4, 8, 16, 32, 64, and 128. So, 6 zeros and 2 1s is equal to 3, because you got a 1 and a 2. 3 1s is equal to 7, because you got a 1, a 2, and a 4. 4 1s is equal to 15, because you got a 1 and a 2 and a 4 and an 8. And then for the higher order bits, 2 1s and 6 zeros is 192, because that's 128 plus 64. 3 1s and 5 zeros is 224, because that's 128 plus 64 plus 32. And then 4 1s followed by 4 zeros is equal to 240, because that's 128 plus 64 plus 32 plus 16. This is understanding binary math. So the way one computer can send the number 7 to another computer is by sending a different combination of positive and negative impulses. Each positive and negative impulse is called a bit. When you have 8 bits together, it's called a byte. Back to a packet. So a packet is a message which is sent from one computer to another computer. The packet includes the data, that is what we're sending. So in this case, one computer is simply trying to send the number 7 to another computer. But this packet is a signal which is going to go on the wire, and it will hit all of the computers. So how does each computer know whether or not the packet is for it? And the answer is the header. The header is a part of the packet that shows who the packet is going to. So when Workstation 3 is sending a packet to Workstation 1, the packet might hit Workstation 2, but Workstation 2 reads the packet header and sees it is not for Workstation 2, so it ignores it. When the packet hits Workstation 1 reads the header, sees that the message is for Workstation 1, and then it receives the data, which is the number 7, into its memory. That is a packet. It's made up of data and a header. Well, actually, if we look at it in binary, this is what a packet looks like. We have the header here, and the header says it's going to Workstation 1. And the data that we're sending is the number 7. And this is what a packet is. We will look at packets in greater detail, and we will see that packets have really more in the header than simply the destination. The packet will also have the source address and other things such as error checking. But the fundamental components to understand in a packet are the data, which is being sent, and the header, which is who it's going to. Binary is tough stuff to get. But if you can understand that 3 1s equal to 7, then you understand binary. Chapter 1, Summary. In this chapter, we discussed the components of a personal computer, and then we looked at the components of a local area network. We looked at a peer-to-peer network and a server-based network. We looked at different types of servers, such as file servers and print servers, and most importantly, domain controllers. We discussed local area network and wide area network. We saw that a packet is a message which has data and header information, and we saw that computers send packets over the wire in the form of binary coding. And this concludes Chapter 1. Thank you very much, and have a nice day.